Assalamu alaikum everyone. So we have to discuss a little bit on trigonometric curves before moving on or stepping on to simple harmonic motion, because the circular motion, the trigonometric curves are really going to be useful when we consider simple harmonic motion, right? So how so? So we will do a kind of initially we will come up with the trigonometric curves that we have already drawn. So let me introduce you guys to the cos curve. The biology students, of course, what they really do is they are dealing with degrees, right? They say 30 degrees, 45 degrees, 60 degrees, and so on and so. But the mathematics students, of course, what they are going to do is they will be dealing with radians, right? So they are very familiar with radians: pi by 4, pi by 2, pi by 3, pi by 4, 3 pi by 2, 3 pi by 4, and pi, and these kinds of things are very familiar for the mathematics students, right? Now, to kind of get off an introduction on the trigonometric curves, so we will start on with the cos curve, right? So cos curve, how is it going to move on, right? So let us draw a kind of a graph like that. Let's say it's starting from 0. So let's say the cos curve is going to start from 0, right? If that was the case, what is really going to happen is now cos 0, the range of cos, if this was x and if this is cos x, the range of x is going to vary between 1 and minus 1. So cos x is going to vary between minus 1 and plus 1, right? If there was a coefficient like this, let us say v, right? If there was a coefficient like that v, so the range is going to vary from minus v to plus v, right? So minus v to plus v, right? Now, if you have pi by 4, cos pi by 4 will be on the first quadrant. The cos is positive. So pi by 4, cos pi by 4 is going to be square root of 1 over root 2. But you have v, right? Instead of you don't have 1, but you have v, so it's going to be v by root 2. So let's say v by root 2, right? Somewhere around here. So this is what is going to be, right? So the next one is, if you have pi by 2, cos pi by 2 is how much? Cos pi by 2 is equal to 0, right? Cos pi by 2 is equal to 0. Cos 0 is 1. So you have a kind of a curve like that, right? So let's draw a little bit, So you're going to have a curve like that, it's going to be reducing like that. So when it comes to minus, 3 pi, when it comes to plus 3 pi by 4, when it comes to 3 pi by 4, what really going to happen is, you're going to get minus v by root 2, And when it comes to pi, it all of a sudden becomes minus v. So this is how the curve is going to vary. And furthermore, if you have 5 pi by 4, and then you have 3 pi by 2, and when you have 7 pi by 4, and 2 pi, right? The curve is going to vary in this fashion, right? So these are very very basic stuff, which you already know. So you are going to have a curve like that, right? So this is going to be your curve, right? So this is going to be your curve. So when it is 3 pi by 2, it should be at 0, and when it is at 2 pi, you again get 1. So this is how the curve is going to vary. So we were also talking about a kind of a circular motion involving with this trigonometric curve with the simple harmonic motion. So how is that? So we are going to think about it, right? So let me draw a circle with radius v, right? So let me draw a circle with radius. Of course the radius is going to be the amplitude, right? The radius is going to be amplitude, but for the sake of understanding, we will get the radius to be v here, so that we will understand how things work, right? So now let's say a particle is somewhere around here, right? The particle is somewhere around here, and it is performing a circular motion, right? Let's say uniform circular motion. So wherever you get, right, wherever the position is, doesn't really matter. The magnitude of the velocity will be v, right? Magnitude of the velocity will be v, right? But the only difference is that the direction is going to change. The only difference is that the direction is going to change. So this is how the velocity of the particles gonna change, right? So v, but these are the velocities of the particle going to change, right? So why are we discussing this now? Now think, simple harmonic motion is kind of an oscillation, right? It's a kind of an oscillation. It's moving like that, coming there, and then moving there. So it's a kind of an oscillation. But you have to remember that during this oscillation, what happens, right? The velocity is maximum when it's at the center or the equilibrium point, and the velocity is slowly going to reduce, and come to rest, and then it's going to be turning back, and it's going to move like that, and the velocity is increasing. Velocity is going to increase, and slowly again the acceleration after the equilibrium point, the acceleration is going to be in the opposite side, and it's going to be slowly reducing, and it's going to come to rest, and then it's going to move like that. This kind of a motion is going to continue. But the obvious point is that when the velocity is on one direction, the acceleration will be on the other direction. So that is the main point you have to understand, right? Similar to the displacement. If the displacement is on one side, the acceleration will be on the other side. Similarly, when the velocity is in one direction, the acceleration is going to be on the opposite direction. So the point being, let's say the particle is starting from this point, right? Particle is starting from this point. So it will have the maximum velocity, right? So the maximum velocity in this direction, right? So we will assume this to be the velocity. So we will assume this to be the same velocity, right? So when it comes a little bit, somewhere around here, right? So what we are going to assume, right? This is not the exact model, but this is kind of a model. It's a very beautiful model to understand simple harmonic motion. So when the particle is somewhere around here, right? What we are going to do is, now look what happens when the particle comes here, right? So it will have a velocity component like that. Similarly, when it comes at this position, what really happens is it has a velocity, but since this is a simple harmonic motion, the velocity is going to slowly reduce, right? Slowly reduce, and it will have a value, right? It will have a value. Now if I draw a line like this, and if this was theta here, right? So this is also theta. If this was theta, this is also theta, this is also theta. Now we are going to consider the horizontal component of this velocity. So we are going to consider the horizontal component of this velocity. So what is the horizontal component? V cos theta. So V cos theta. So V cos theta will be the horizontal component, V cos theta. So this value of the velocity is same as this value here. So this will be the theta value there, right? When the particle is here, you are going to have a V cos theta value, right? Theta is now slowly increasing. When theta is increasing, cos theta should reduce. So you will get the V cos theta value to be this, right? You see that, the corresponding values, you are going to get it straightly, right? So if this is V, here also you are going to get V. Now here also it's V, but it's a little bit slanted, right? You have an angle here, so you have an angle there. So according to that angle, this velocity of in the horizontal direction is going to change, right? So this is a cos curve, so it's going to go like that. When it is pi by 2, right, at this position, what happens in a simple harmonic motion? What happens actually is, the particle is going to go like that, stops, and then turns back and moves, right? Stops. The word stop is very important. So it comes here, right? From here to here it moves, stops, and then moves. So even though if you consider it as uniform circular motion, you have a velocity component. Obviously you have a velocity component, but the velocity component is straight vertically downwards, right? So the horizontal component of this is going to be V cos pi by 2. Cos pi by 2 is how much? Cos pi by 2 is simply 0. When V cos pi by 2, V into 0 is 0, the horizontal value is 0, and you get the same exact value when it is pi by 2, right? Similarly, when it comes down, you get the velocity, like that. When it is at the minimum value, you get the minimum value, right? So when it comes here, right, so it's a kind of a motion like this, right? What you have to do is to just draw a vertical line and figure out where the position is. So it's going to go like that, and it's going to turn back, and this kind of a motion is always going to continue, right? So whatever it is, according to this value, it's going to change. The meaning, when you have V, the horizontal component of V is V. So when you have V in that direction, the V cos theta is going to be this value, and you have a kind of a beautiful pattern which is going to work for for the simple harmonic motion when it is considered as a circular motion, right? So we are just going to move on with that, right? So the obvious point that you have to understand is the on the last video we have written an equation x double dot plus omega squared x is equal to 0. Now what is this omega? The omega of this is actually, you know, v over a, because a is the amplitude, so v over a. So you have to understand that this is the angular velocity. What I mean is angular velocity, right? So the omega squared x, in that you know, you have omega. The omega is of course the angular velocity. Okay.